Hello. Let me not. I'll cut this. Hello, my name is Mesdjian. I'm going to be going over how to download, compile, and run our code. So here I am on the GitHub page for our project. So I'm just going to go ahead and copy the HTTPS so we can clone this. And then I'll go ahead and open up a mini conda. And then I'm just going to cd into my desktop. You can put this wherever you want, obviously. I'll just paste the... Yep, okay. So now I'm just going to open my editor of choice. I'm going to use VS Code. All right, so now we can see all the files we have here. In the params.txt we have, you can kind of set more variables as you want easily, so you don't have to go into the actual files. So yeah, let me just go ahead and run them for you. So to do that, we're just going to do, let me cd into the directory first. So we have to go to there, and then it should be just Python, and then the file names. So we have two main ones, the circle CUDA3, which is our parallel code, and it runs in that amount of time. And then it also generates this video. So let me go ahead and show you that. And then we'll look at the other files that also run this. So yeah, this is kind of what our project generates. It's like a colorful circle with these lines drawn on it, and it utilizes the GPU to do this. All right. So let me just delete this to show that our sequential code also is able to generate that. And so we see the video also popped up. And it turns out that our sequential code is slower than our parallel code, which is good, right? We showed that using the GPU is beneficial. And here's the video again, just to show it's the same thing, right? Okay.
Hi, my name is Charles, and I'll be explaining the implementation. So the code generates a video, and each frame contains a circle that's shaped like this, with a bunch of lines. In this circle, there are n evenly divided points. So for this circle specifically, there are 160 points, and the ith point connects to the factor times ith point. If I times factor is too large, it is modded by n, which is the total number of points. Factor can be any number you want. So for example, factor is 2 in this circle specifically, which creates a cardioid image. So this is our code. We implemented in Python numba with a numba library. This is our main kernel function. The @cuda.jit signifies this function will be run on the device. Since each frame has a different factor, we calculate the factor by using thread ID and block ID. Every single thread uses the same procedures to draw the lines. As you can see in this kernel function, the CUDA.jit flag is similar to the __ kernel flag in C. And then scroll down to the memory allocation. Yeah, so we have to first allocate memory on the device. This array is a very big array. And you can think of it as an array of frames. And every single frame will be parallelized by each thread. Yeah, so we first allocate into the device so we don't have to copy anything over, since we are drawing the frames from a blank canvas. The frames will then be filled after the kernel call and copied back from host. As you can see, there's a line that copies to host. Line 79, yeah. And then the CPU will use OpenCV to generate the video in sequential code. So only the filling of frames is in parallel. Everything else is sequential.
Okay, now I'm going to go into our individual implementations for drawing the circle and kind of explain how they differ. So in our sequential implementation, obviously it's sequential. So we just draw the lines on the CPU using this main driver code with the double for loops where we go through each frame and then we draw each line. As for the first CUDA code, we are able to basically call this this for loop inside of the kernel. I will say though, this first CUDA code parallelizes by doing each line in parallel, as opposed to our later implementations, which instead do it parallelize the frames. So the 2 and 3 do frames in parallel, while the first CUDA does lines in parallel. And then the difference between 2 and 3 is that in 2, we actually make the video frames array on the host and then copy it to device, whereas in 3, we actually allocate it on device and then just copy it back to the host, which saves us a bit of runtime. So now I'm just going to go ahead and look at the execution time of all 3 here. So let's just do Python, and then we'll do Python, and then we'll do the circle stack first. And that runs in about 1.1 seconds. And then we'll do CUDA. And that is a bit slower. After compiled run, it's still slower than the sequential code. I'll do 2. Here we actually start beating the sequential code when it's doing the after compiled run at 0.48 seconds. And then, yeah, so we can see in Circle CUDA 3, we also get better compiling and runtime than CUDA 2, and marginally better after compiled runtime. So then one other thing we should show is that in params.txt, if you set the frames too high, you'll actually run into a problem where you run out of memory on your GPU to yeah, let's really crank it. I don't know. On the test GPU we were using, it failed at 120, so we'll see. Okay, yeah, there we go. So yeah, we ran out of memory. So yeah, that's just something to look out for. If you set the height or width too great, plus like making the frames per second too high, then you do run into that error. Just something to be aware of. All right.